Hello, my name is Brian, and this is number 2. So basically, I'm solving a problem of air entering a partially open valve inside a ventilator, which has a steady flow rate of 5 centimeters H2O to keep the patient's lungs open. And I am trying to require the rate, the mass flow rate of the air. That is what I'm trying to find. So I set up the equation to save some time. This is the balance energy equation. It relates to the first law of thermodynamics. So in the system, work can be neither be destroyed or created. So here in the problem, just to describe it, where I got the stuff, this is actually the internal energy, which is described as delta Q minus delta W. My kinetic energy is actually this, and my potential is this right here. And my mass flow rate and H, I got 8, and I used enthalpy because of the chemical reaction that happens through the system, which takes account of the internal energy plus the pressure, the constant pressure times the volume. So with this being said, our energy of the system, it states that it's steady state, so that means it goes to 0. Here we are neglecting any stray heat transfer of the surroundings, so this goes to 0. We're neglecting kinetic and potential, so both of these go to 0. So if I rewrite this, it's 0 equals my negative work plus my mass flow rate times H1 minus H2. I can add to the other side my work, which is going to leave me with positive delta W equals my mass flow rate H1 minus H2. So here I have my givens from the problem. Here I'm gonna convert, so I'm gonna add 273, and with 15 I get 288 degrees Kelvin, and here I get 310 degrees Kelvin. And I'm using that because on table A22, the values of temperature in Kelvin. So if I look at 310 degrees Kelvin, I'm gonna define that as my H2, which equals 310.24, and then at 288 degrees Kelvin, which is my H1, that I am gonna solve. So if I interpolate, you do 290 minus 285 over 290.16 minus 285.14 equals 285 over H1, 285.14. So my H1 turns out to be 288.152 kilojoules per kilogram. So I plug these values in. So my work is given. So 1.9 kilowatts equals my mass flow rate times 288.152 minus 310.24. If I solve this, my mass flow rate is going to equal negative 86.02, and this is watts per kilojoules per kilogram, and I need to convert, so I know 1 kilojoules per second equals 1000 watts. If I convert that, my flow rate is actually negative 0.86 kilograms per second. So what this negative means is that I was assuming that the flow rate was going in through the inlet and then out through the outlet. But in reality, it actually shows that the flow rate is reversed. So it's actually going the opposite direction. That's why it is negative.